Manganese heptoxide is extremely dangerous. It's an extremely strong oxidizer and it can easily ignite clothing and almost all organic material. It can also be potentially explosive and must never be heated or subjected to a strong impact. You should always be very careful when you handle it. When working with it, you must absolutely wear a lab coat and goggles at a minimum. Gloves are not recommended because the manganese heptoxide can violently ignite them. In general, you should only prepare this compound if you're ready to accept the risks involved. It is very dangerous and you must treat it with the respect that it deserves. Manganese heptoxide can be easily synthesized by adding potassium permanganate to an excess of concentrated sulfuric acid. First, add the sulfuric acid and then drop in some potassium permanganate. Then, lightly stir the mixture to make sure that all of the potassium permanganate reacts. The manganese heptoxide is formed according to the equation above. Initially, HMnO4 is produced, but this is quickly dehydrated by the sulfuric acid to form the manganese heptoxide, or Mn2O7. You should add cold sulfuric acid to limit the temperature increase of the addition. The manganese heptoxide can become explosively unstable at temperatures higher than 55 degrees Celsius. You can add more potassium permanganate to achieve the desired consistency and to increase the concentration of the manganese heptoxide. The more potassium permanganate that you add, the more manganese heptoxide will be synthesized. However, if you add too much, it will solidify into a solid clump. Note that this must only be synthesized in an appropriate container. Only carry this out using a glass or metal container, as the manganese heptoxide will oxidize any organic material. So definitely do not carry this out in anything made of plastic. In the clip that I just showed, the manganese heptoxide explosively oxidized the acetone. This violent and exothermic reaction should occur with most, if not all, organic solvents. In general, it oxidizes most organic materials to CO2 and water. In this shot, an interesting reaction occurs with standard printing paper. The concentration of the manganese heptoxide was high enough to oxidize the paper, but it was not high enough to cause the paper to ignite. This effect is interesting as it appears as though the paper is simply melting into the solution. In the higher concentrations, the manganese heptoxide quickly and violently oxidizes the paper. Again, tried with paper towel, there is a quick pop and the paper immediately bursts into flames. This is just to show you that sometimes when the material is added to the manganese heptoxide, it does not ignite immediately. Sometimes it can take several seconds for the ignition to occur. It is best to leave it and wait instead of pulling away the now manganese heptoxide soaked material. Next, I tried cotton, which seemed to react much more violently than the paper. I attribute this to the fact that the surface area of the cotton is going to be much greater than that of the paper. To neutralize the potentially explosive manganese heptoxide, simply add water. I put my entire metal piece that was covered with manganese heptoxide into a beaker of water. The water will break down the manganese heptoxide into permanganic acid. The color of the manganese heptoxide will convert from a dirty greenish brown color to a very nice purple color. If you leave this purple solution out for a day or two, it should completely break down into manganese dioxide, which is brown. Even after 30 minutes, you might notice that the solution starts becoming brown. I suggest leaving the beaker out for a few days so that everything can break down into manganese dioxide. The manganese dioxide is insoluble and will sink down to the bottom of the beaker. Then the relatively inert, solid MnO2 waste can be disposed of.